morning students, Jai Swaminarayan. Today we are going to revise chapter 3 trigonometric functions. And students, the most important thing that exercise 3.4 trigonometric equations has been removed. So we will not take any questions from that particular topic. Okay students, starting with conversions of degree to radian and radian to degree measure, the formulas. Now students, all of you know that radian measure Rn is equal to pi by 180 into degree measure. Radian measure Rn is equal to pi by 180 into degree measure, and conversely degree measure is equal to 180 by pi into Rn, and pi radian is equal to 180 degree. This is what students you have to memorize and remember. Then 1 radian is approximately 57 degree 16 minutes, and 1 degree is approximately 0.01746 degrees. This result, students, can be asked as MCQ. So students, this results you have to memorize. Now 1 degree is 60 minutes and 1 minute is equal to 60 seconds. This also, I suppose, all of you easily remember and revise it. Students, this is such a topic that it is very useful. In physics also, it is useful to some extent. In chemistry also. In your engineering, throughout, you will use this. So this is the topic which is to be concentrated on. Now students, in exercise 3.1, we revise few sums. The first question, convert the following degree measures to radian. Let us do the second part of main question 1. Exercise 3.1, main question 1, part 2. Theta is given minus 47 degree 30 minutes. Now students, as far as angle convention is considered, now students, as far as angle conversion is considered, negative sign indicates clockwise and positive sign indicates anti-clockwise. Convert second to minute, minute to degree, and degree to radian. This is the chronology, students, which we will follow. This is the chronology, students, which we will follow. Here there are no seconds, so minute to degree. 1 minute is 60 seconds, and 1 degree is equal to 60 minutes. So 30 minutes will be equal to 30 upon 60 degree, and that is half a degree, and that is, students, half a degree. Add this to the given as a fractional part, so minus 47 integer by 2, and that is minus 95 by 2 degree. Now apply the formula. Radian measure is equal to pi by 180 into degree measure. So pi by 180 5. 19s are and 5. 36 are, so minus of 19 by 72. Here is our answer. Students, this is very important in your physics and chemistry, especially in physics. This is, students, very important. Negative sign only indicates that the angle is considered clockwise. That means only you have to do that. Now, main question 2. I am doing part 1. Theta is given as 11 by 16. Okay, now students, one has to be very careful and very cautious here. Now, from degree to radian, the conversion was second to minute, minute to degree, and degree to radian. Here, radian to degree, degree to minutes, and minutes to second. So, the convention and the chronology changes. Convection and chronology changes, students, here. That's all. That much only, students. You have to remember. So, apply the formula. Students, apply the formula. Here it is given radian measures dn is equal to 180 by pi into radian measure. So 180 into 7 by 22 into 11 by 16. This many days. Go at ease. 11 ones are 11 twos are 2 ones are 2, 90s are 2, 45s are 2, 8s. Students, go at ease. One has to be very cautious. Go at ease. Now, 45 into 7. 7 5s are 35, 7 4s are 28, and 3 31. So this becomes 315 upon 8 degree. Now, students, from radian we have converted to degree. Now, degree to minutes and minutes to second. Go by simple division. Divide 315 by 8. 8 3s are 24, 11 minus 4, 7, 5, 8, 9s are 72, so 9 is 3, quotient is 39, this is divided in the form Q R by D. So, 39 integer 3 by 8. Convert the fraction to mixed fraction and write it as 39 degree plus 3 by 8 into 60 minutes. 4 2s are 4, 15s are 45 by 2. So 22 and a half. I am writing directly. So 22 minutes, half minute is this many seconds. 2 1s are 2 30s are. Final answer is 39 degree, 22 minutes and 30 seconds. So here we have to go by simple division without using your formal calculator. This is the main part. Students, revise this. This exercise, according to me, is the most interesting one. Now, students, we go further. Next, students, we go further. next formula will revise. Now, students, in the next formula, say we have a circle. Say this is an arc AB. Arc length is L. Radius of the circle is R. Center is C. Angle subtended is theta radian. Then arc length, students, L is equal to R theta radian, or theta radian is equal to L by R. So in a circle of radius R and arc of length L subtends an angle theta radian in the center of the circle, then students, we have L is equal to R theta radian, or conversely I can say theta radian is nothing but L by R. This formula, students, you have to remember. Now let us do some number 5. In a circle of diameter 40 cm, a chord of length 20 cm is given. Find the length of minor arc corresponding to the chord. Say, the question is from number 5, students. 3.1. Say this is the circle. This is the chord AB. C is the center. Diameter is 40 centimeter. So radius will be 20 centimeter. So AB, BC and AC all are equal. So this is an equilateral triangle. So theta will be 60 degrees. This one, students, all of you can easily understand. And we have to find this minor arc AB, which is having say length L units. We have to find minor arc AB in terms of length. Now, triangle ABC is equilateral, therefore theta is equal to 60 degree for triangle ABC. AB is equal to BC is equal to AC. Therefore theta is equal to 60 degree, and 60 degrees pi by 3 radian. Before using this formula, students, you should convert theta from degree to radian. That is the main part of the sum. So now, using the formula, L is equal to R into theta radian, 20 into pi by 3. We can keep this as 20 pi by 3 centimeter, or 20 by 3 into 3.14 centimeter. Use your simple calculator to get the answer. So this is easy, students, but you have to understand its application. Its application is very vital. The formula L is equal to R theta, students, has a variety of applications, of which one of the applications is this, students, what we have shown. So it is not possible, students, to do all the sums, but I have tried to cover maximum concepts in one sample problem, students. Now we are revising exercise 3.2. 3.2. Students, we have all STCD. Students, in exercise 3.2, we have students all STCD. Let us draw the unit circle. Say this is x-axis. Say this is y-axis. And say this is a unit circle. So this is A, B, A dash, B dash, here 1, 0, here 0, 1, minus 1, 0, 0, minus 1, center is of course origin. I am not good at drawing, but students, we have to vary this. Now actually, what is all STC rule? Say if I take any point P on the circumference of the circle, say in first quadrant, then this ray of P makes angle theta radian with positive direction of x-axis, then x coordinate is cos of theta, and students y coordinate is sine of theta. This is, students, you have to remember, and this can be easily derived also. Say I draw a perpendicular. Now distance OM is x coordinate, distance PM is y coordinate, this is radius. You know, students, a circle with center origin and the radius 1 unit, students, is called a unit circle. A circle with center origin, students, and radius 1 unit is nothing but, students, a unit circle. An equation of unit circle is, students, equation of unit circle is x squared plus y squared is equal to 1. So we could have easily derived x is equal to cos theta and y is equal to sin theta. Triangle PMO is a right angle triangle, so sin of theta will be opposite upon hypotenuse, so y by 1, so y is sin theta. Cos theta will be adjacent upon hypotenuse, so hypotenuse is equal to x is cos theta. So, on a unit circle, if we have the point x, y, and if ray of makes an angle of theta in the positive direction of x-axis, then students, I can have x is equal to cos theta, and students, we can have y is equal to sine of theta. Students, this much I think all of you can easily understand. Now, why this all STC rule, students? How this all STC rule has been derived? Now, in first quadrant, x and y, both the coordinates are positive. So I write this as x dash and I write this as y dash in first quadrant. X-axis and y-axis have positive stance. Therefore, cos theta and sin theta are positive. If cos theta and sin theta are positive, all 60 functions will have a positive sign. So students, we have all, means all t functions in first quadrant are positive. Now in second quadrant, x-axis is negative, so cos theta is negative, y-axis is still having a positive stance, so sin positive. Sin positive means cosec also positive. If sin theta is positive, its reciprocal will be also positive. This, students, you have to understand as well as memorize. Now in third quadrant, x and y both are negative. So if sin theta and cos theta both are negative, tan theta will develop a positive sign correspondingly cot. In fourth quadrant, cos theta is positive, x is positive and y is negative. So see, cos cos and sec both are positive, and this gives the students all STC rule. So this is the fundamental for students all STC rule, which one must easily now memorize as well as students remember. So this is the fundamental students of all STC rule. Now let us do two sums based on all STC rule. Exercise 3.2. Now students, I am doing the first sum. Cos x is equal to minus 1 by 2. X is in third quadrant. Exercise 3.2. First sum. Cos x is equal to minus 1 by 2. X is in third quadrant. Okay. In this type of sum, these are algorithmic sums. Students, these are algorithmic sums. First of all, draw a right angle triangle. And this is x. Cos is adjacent upon hypotenuse. Let us name the vertices as ABC. So students, measure angle B is equal to 90 degree. Okay students, I want to find side AB. According to Pythagoras theorem, AB square plus BC square is equal to AC square. So AB square plus 1 is equal to 4. So AB is equal to 3. This much all of you can easily understand. So students, in this type of sums, one has to be very careful. I did not write minus 1. Length of the side of the triangle is well. We did. Students, negative sign is a due consideration with respect to quadrant. As x is in third quadrant, that is why cos x is there in the negative sign. Now, immediately you should write sine of x is equal to AB upon AC, and it will bear a negative sign due to quadrant, so it is minus 2 3 by 2, because in third quadrant, tan and cot, only two functions are positive, remaining both are negative. Immediately you can write cosec x will be minus 2 by root 3, and here also immediately you can write sec x is equal to minus 2. Now, tan x is equal to AB upon BC, third quadrant, so positive, so root 3 by 1, so root 3, and cot x is reciprocal, so 1 by root 3. Check this to bear a positive sign, and the remaining are 80. This is what students we have to understand and memorize. This is the most important part. One more problem of this type, students, we are solving so that we can understand the concept and application of students all STC rule. Okay, sec x is equal to 13 by 5. X is in fourth quadrant, fourth sum. Sec x is equal to 13 by 5. X is in fourth quadrant. Okay, students, fourth quadrant. So immediately you should write cos x is equal to 5 by 30. And it will also bear a positive sign. So if I construct a right angle triangle, and this is x, this will be 5, this is 30. Pythagorean triplets, if you remember, this would be 12. In your 10th standard, you will been told to memorize, students, Pythagorean triplets. I remember very well. So you would have been told. So x is in fourth quadrant. So sine of x will be minus of dt upon ac, because in fourth quadrant sine will be negative. So minus 2 by 30. Immediately write its reciprocal. Cosec will be minus 13 by 12. And tan of x will be minus of AB upon BC. So minus of 12 by 5. So cot of x will be minus of 5 by 12. This will be also negative. In any quadrant out of 6, 2 will be positive. Meaningful students will add a negative sign. Now students, value-based sums, value-based questions, most of you are still making mistakes. Value-based problems, still most of you students are making mistakes. That should not happen, students, at the end of the chapter or at this particular level, students. You shouldn't be making mistakes in value-based problems. First, remember this set of formulas. Sine of minus x is minus sine x. Cos of minus x is cos x. Tan of minus x is minus tan x. Cot of minus x is minus cot x. Sec of minus x is sec x. And cosec of minus x is minus cosec x. The proof of this formula for the time being I am not going for. Now I am doing sum number 7. Sum number 7. Find the value of cosec minus 1410 3.2. Sum number 7. Find the value of cosec minus 1410 degree. Now, students, pay attention. This value-based problem deserves a lot of attention. First step, cosec of minus x is written as minus cosec x. So write this as minus of cosec 1410 degree. Now, 2 pi radian is 360 degree. So 4 pi radian will be 720 degree and 8 pi radian will be 40 degree. This much easily students we can understand. Pi is 180 degree, so 2 pi will be 360, 8 pi will be 40. So this is replaced as minus cosec of 1440 degree minus 30 degree. So this is 8 pi, and we can consider this as theta, and this theta must be always acute. Clear? So 8 pi, all even pi's will be at a 0, 2 pi, 4 pi, 6 pi, 8 pi, and onwards. Minus theta will fall in fourth quadrant. So first of all, I write this as cosec 30. Now this negative sign is intact, which is outside. Now 8 pi minus theta lies in fourth quadrant, and in fourth quadrant cos and sec are positive, cosec is negative. So one more negative sign is multiplied, so this answer is 2. 8 pi minus theta will fall in fourth quadrant. according to Wallace DC rule, in fourth quadrant, cos and sec are positive. Remaining are negative, so cosec will bear a negative sign. So outside negative into negative becomes positive. So the answer is 2. Cosec 30 is 2, sin 30 is given by 2. This is how you do the sum. One more, 8 sum. Find the value of tan of 19 pi by 3. So this was in radian, this is in degree. This is in radian, this was in degree. Fair, not at all an issue. Concept, logic and method, students, remains the same. Now in this type of sum, express your numerator as a multiple of denominator. So 19 pi is written as 80 pi plus pi by 3 radians. Take individual division, so this is written as tan of 6 pi plus pi by 3 radians. Now all even pi's are at A, I told, and all odd pi's are at A dash. 6 pi plus theta will fall in first quadrant. It is whether it is a multiple of pi or a field of the function doesn't change. So this answer is tan of pi by 3 only. Now first quadrant all t functions are positive, and so this answer is root 3. Whenever here we have a multiple of pi, so this function doesn't change. And whenever we have a multiple of pi by 2, cosec will change to sec, and sec will change to cosec, sine will change to cos, and cos will change to sine, tan will change to cot, and cot will change to tan. This much, students, you have to remember and memorize. This concepts are very important, not only for 11th standard. Students, throughout your 12th standard, Wallace DC rule. This sine of minus x is equal to minus sine x, cos of minus x is equal to cos x. This is based on the concept of functions which are even odd, but at present, students, the proof of this formula is beyond your scope. So, students, we are not involving into formulas, means proofs of formulas. Okay, students, the remaining concepts will be discussed by sir in the next lecture. Here we conclude the lecture. Thank you, students. Study well, study perfectly.